Hello students, welcome to the second chapter of the PYQ. I'll be doing previous year questions from last 5 to 6 years where the questions of the haloalkanes, haloarenes they have asked. And see why PYQs are important. PYQs, previous year questions, gives you the idea about the paper, what kind of questions can be asked. See, as far as learning is conceptually, when you learn, that time you don't have to look at the papers when you learn as a subject. But when it comes to the answering paper, you have to give a look at the previous year questions so that you can focus on the certain things, and that can give you a good edge to your preparations. So that's why PYQs is important. Where to focus, what type of reactions you need to study, how many kinds of conceptual questions are asked. All these things, all the information is understood only by looking at the previous year question. So I have clubbed all the questions of the haloalkane, haloarene. Let's go ahead. So first question, if you see over here question asked is, this question is for the 2 marks, 1 mark for this, and second sub question is this. Okay, so for 1 mark they have asked which halogen compound from the following will undergo SN2 reaction faster. For now this is one question which is asked, not necessary that same question will be asked in an exam, right? In your exam, not necessary that the same question will be there, but you have to learn the concept in and around of this. Like they have asked for a SN2, the question may come for SN1 in an exam. For that, you have to know the difference between the SN1 and SN2 mechanism. So I'll just write, before I solve this question, I'll just write the difference between a SN1 mechanism and a SN2 mechanism. So I'll write over here, this is SN so SN1, just will make this difference clear, and this is other is SN2. First difference, SN1 mechanism order, like if you ask me primary, tertiary, secondary alkyl halide, then it is most favorable for the tertiary alkyl halide. Right, and over here this is most favorable for the primary alkyl halide. This is the ideal condition for the SN2 and this is ideal for SN1, right? But order of the reactivity or order of the in which direction, in which mechanism will be followed is this. Order will write tertiary is more favorable, then secondary, and then primary. Okay, over here primary is more favorable, then secondary, and least is what? Tertiary. This is one thing, this is one difference you should know. Second major difference you should know about this is that there is formation of the carbocation, carbocation, and here no formation of carbocation, no formation of carbocation. Okay, I'll write it this way. So this is the thing. Then a third difference, this is two-step reaction. SN1 is two-step reaction, and this is one-step reaction. Okay, this is the second difference. Fourth, we can write there is racemic product, racemization takes place, and here there is inversion of the configuration, you get inversion of configuration takes place. So since this question is asked, you should be knowing all these four major differences about the SN1 and SN2. Let us come back to the question. Select the correct compound from which of the given pair, which halogen compound from the compound will undergo SN2. Now if you ask me what degree alkyl halide is this, means what is it, primary alkyl halide, a secondary alkyl halide, or a tertiary alkyl halide? So let us draw the structure 1, like this is bond line structure. Let us understand the open chain structure for this. For the structure A, I'll write this as a carbon, this as a carbon, this as a carbon, over here this is a carbon, and this is also a carbon. Next, this is carbon, over here there is a Cl, and this is what? There are hydrogens, which we don't show in a bond line structure. We put the number of hydrogen in such a manner that the valency of the carbon is satisfied. This is the structure, open chain structure of the structure A. Now this is the alkyl halide halogen. This is the halogen which is connected to the carbon. It is further connected to only one carbon. So this is what the definition of the primary alkyl halide. This is primary alkyl halide. And this one, this is the carbon, means I'll draw the structure of the B also. This is the carbon, over here this is carbon, and this is Cl, right? So this is the halogen is connected to this carbon, this is directly connected to carbon. So this is secondary alkyl halide. So primary alkyl halide SN2 reaction is more favorable, so the answer is option A. A compound is more favorable for the SN2 reaction. Next question, which of the following molecule or given pair is chiral? Now we have to understand the meaning of the chiral. You have to just tell answer. You don't have to give the explanation for this type of question. Just 1 mark. This question is just for the 1 mark. Definition of the chiral or a chiral is not asked. What is the meaning of chiral? What is the meaning of chiral? 1 minute. What is the meaning of chiral? Chiral carbon or asymmetric carbon. The definition is very simple. First I will write the definition. A carbon on which all the 4 groups attached to it are different. Okay, carbon having all 4 different groups. That is what the meaning of the chiral is. If you write this structure, this is CH3, CH2, 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 Br, means this is my first carbon. Like this is how I'll write CH3. This is CH2. This is 3. This is 4. And this is Br. And the other structure I'll write over here. This is CH3. Okay, so this is what I have written the open chain structure for both the compounds. We have to understand which one is a chiral, okay, or what we can say the compound, even if the compound is, okay, first we'll understand which one is chiral, then I'll tell you more story about this chiral thing. The chiral definition, a carbon having all 4 different groups. Okay, carbon having all 4 different groups, or the 4 bonds connected should be different. Over here, this is achiral because there are similar hydrogen. 3 hydrogen atoms are there. Here there are 2 similar groups, that is hydrogen and hydrogen. Here there are again 2, here again there are 2. So in this case, no chiral carbon, no chiral carbon, chiral carbon. Okay, and over here if you see, this is not a chiral carbon because 3 hydrogen, same group. We'll talk about this later. This has 2 hydrogen, this has 3 hydrogen, means here the groups are repeating. But if you check over here, this carbon is chiral, means asymmetric carbon. This hydrogen is different from CH3, and this is what? C2H5, and this is Br. So here all 4 groups attached to it are different. That's why this is chiral. Now the possibility, the answer for this will be this one. This is the answer for this. Now same question, same question could be asked for an exam. That time you shouldn't be getting confused. Question could be asked this way. Okay, which of the following compound is optically active? Which of the following compound is optically active? This could be a different way the questions could be framed. You know chiral, means you should know the optically active compound. So what we can say is that if the compound is chiral, means asymmetric, then it is optically active. Means there is a presence of at least one chiral center, means the compound is optically active. And what about this? Achiral means or symmetric means optically inactive. Now what is optically active, what is optically inactive? If you want to learn, you can just refer to my stereochemistry series, stereoisomerism, where I have explained all the isomerism in detail. Just refer to my playlist, you will understand. Okay, if you have understood this concept, then give thumbs up. We'll go for the next question. Okay, this question is from the alcohols phenol. By mistake it is over here. I'll do that when alcohols phenols, I'll be doing the alcohols phenols. Okay, this question. Hope the question is clear or it's kind of blurred. 1 minute, I'll check. Yeah, question is clear. Okay, so identify and name the reactions which are illustrated by the following chemical reaction. I'll take first reaction. I'll write first reaction over here. First reaction is given this way. Okay, it is C6H5Br plus 2 moles of sodium plus CH3Br. Okay, and this is C6H5CH3 plus 2 moles of NaBr. This is that reaction. Now, if you have a close look at this reaction in haloalkane and a haloarene, this chapter, we learn 3 similar reactions. I'll illustrate all the 3 similar reactions. Okay, which are those 3 similar reactions? The reactions are this way. One is known as Wood's reaction. The reaction is this way: alkyl halide plus 2 moles of sodium and again alkyl halide. Alkyl halide, you can write it 2 times separately. I'll just put 2Rx. Okay. In the presence of dry ether, you get R plus 2 moles of the sodium halide. Now, this is your alkyl halide or a haloalkane, alkyl halide. This is your alkyl halide. And this is the alkane which you are getting, and this is a salt, sodium halide. sodium halide. This is one reaction which you learn in as a Woods reaction. There is one more reaction similar, it will go similar, that is second reaction over here. Second reaction is Woods fatigue reaction. Understand? Huh? See, when you learn organic chemistry, my dear students, what you have to do is, you have to compare the reaction, how this one reaction is similar to the other reaction, or how this one reaction is different from the other reaction. Just, writing and practicing one reaction 10 times won't help you that way, right? So when you compare one reaction with the other reaction, then you club them and try to understand the differences, similarities between this reaction. What kind of reaction, why we are learning that? Is it a preparation reaction, or is it a chemical property which we are testing about that reaction? When you keep all these things in your mind, your preparation for the organic chemistry becomes very smooth. So next is Woods fatigue reaction. Over here, Woods fatigue reaction are X, that is alkyl halide. Basically, these reactions are where we are testing. These are the chemical reaction. We are testing the chemical reactivity of the alkyl halide and the aryl halide with the sodium metal, because sodium metal is highly reactive. This is what? Aryl halide, right? This is alkyl halide, this is aryl halide, and this will give you, this is that, here R and R is getting connected, this is benzene and this R is getting connected over here. So I'll write this, and this is 2 moles of NaX. So what is this? This is alkyl benzene, this is alkyl benzene, right? And third reaction which you should know is a fatigue reaction. Fatigue reaction is this: aryl halide, 2 moles of aryl halide, you get this. Okay, so this is your aryl halide. This is also aryl halide. Here the product is very specific, that is biphenyl. You will always get biphenyl only over here. This can be variable, this alkane, alkyl benzene. So this is what the 3 reactions. See, when you know the difference over here it is in a Woods reaction, alkyl halide reacts with itself, alkyl halide. In a Woods fatigue, it is alkyl halide and aryl halide, and in a fatigue reaction, aryl halide, one molecule of the aryl halide reacts with the aryl halide to give you what? Biphenyl. So when you understand this difference, any questions which is asked based on this reaction could be easily cracked. So over here, I'll come over here. So what is the name of the first reaction? Like CH2Br, right? So this reaction, if I write this reaction over here, I'll write this reaction. C6H5Br is written this way. C6H5Br is written this way. 2 moles of sodium, and this is what? CH3Br. Okay, and product, what you are getting is this. This is what the product, methyl benzene or the toluene, and 2 moles of NaBr. Now you identify and comment. You can comment on this and tell me what is this reaction. It is aryl halide, you understand, this is aryl halide. This is alkyl halide. So this name of the reaction was asked. Name of this reaction is Woods fatigue reaction. So first answer is what? Woods fatigue reaction. Don't write short forms for the exam, write complete. If you want good marks, avoid short forms. You will simply lose marks because of the short form. Write it complete. Okay? You should be as much as presentable when it comes to subjective writing. It doesn't matter how much you know. What matters is how well, yeah, it matters how much you know. When you know only, that time only you will be able to present. So presenting your knowledge is very important, nicely. Okay. So first answer is what? Wood-Swittig reaction. Now over here, this is C6H5N2Cl. Let's understand this. Right? The reaction is given this way. C6. Second I'll illustrate. This is C6H5N2 plus Cl minus plus HCl plus HCl, then Cu2 Cl2. And C6H5Cl plus nitrogen gas. Right? There is a diazonium salt in this case, and you are getting like it is this. Many times what happens is you know the reaction, you know this, right? C6H5N2, nitrogen is triple bonded, that's why positive charge, and the counter ion is Cl minus for this. This is a salt, this is diazonium salt. This is diazonium salt formed from a combination of the base, that is primary aromatic amine, and the nitrous acid, right? So this is that salt. This is further when reacted in the presence of acid in the cuprous chloride, you get this chlorobenzene, haloarene it is, chlorobenzene, right? And the nitrogen gas is evolved. So the name of this reaction, the name is asked, this name of this reaction you will be writing as a Sandmeyer's reaction. Sandmeyer's reaction, where primary aromatic amine is first converted to diazonium salt, and diazonium salt is later converted to alkyl halide. Basically it is a nucleophilic substitution reaction where halide is acting as a nucleophile and that is being substituted on this diazonium salt. Okay, so last question, what is the name of this reaction? That is third. The reaction is given as, third reaction is given this way. CH3, CH2Cl, AgF, silver fluoride. Yes, no? Silver fluoride only it is given. And CH3, CH2, F plus AgCl. See, this reaction is, there are two reactions which we basically learn in a halogen exchange, like halogen exchange reaction. Halogen exchange, we learn two reactions. One is Phil-Kinston reaction. Please check the spelling of this. To textbook there are different reaction, different spellings. Just check your NCRT. Your means mine, and your everyone's NCRT. Phil-Kinston reaction. And second is Swartz reaction. Swartz reaction. These are the two halogen exchange reaction, okay, which we learn. Okay, Swartz reaction and the Phil-Kinston reaction. This is whenever it is, this is for the preparation of the fluorine. Preparation of alkane, fluoroalkane, very specific, RF. We are preparing fluoroalkane from this. Okay, this is Wilkinson reaction. So basically this reaction is the preparation of this fluoroethane over here. Fluoroethane is formed. So this is a Schwartz reaction, and you have to understand the difference between Schwartz and Wilkinson reaction. Understand that F stands for not Wilkinson. Understand, F stands for something S, that is Schwartz. Many students make this mistake, F for Wilkinson. So learn the other reaction also. So these are the three reactions. If you write just these names and understand how to remember the reaction, you can score good marks in organic chemistry. See, learning organic chemistry scoring, wow, you know, the reason is very simple. You just write one reaction, and you know, if you are very confident on it, you directly get 1 or 2 marks. But when it comes to the physical chemistry, that is kind of bit tough, because you need to do some solving of the numericals. You have to put the right formulas and the units, calculations, so many things you have to take care of in that examination hall, right, under that pressure. So learning organic is always advantageous. It can fetch you good marks. Okay, we'll go ahead. Yeah. Identify the reagent. Okay, acetophenone, aldehyde. Okay, this question is again from the aldehyde, ketones and the carboxylic acid preparation of acetone. Yeah. Yes. In the following reaction, write the name and the structure of the major product E and G. There are two reactions. One right side. So basically, first reaction is a chlorobenzenes. First we'll do this, we'll sort out this. How you have to write for the exam? You have to be very much clear, systematic. This is our chlorobenzene. This reaction concentrated HNO3 in the presence of concentrated H2SO4, right? I'll do it on the other page. Space won't be enough. We'll talk about this first reaction. There is a chlorobenzene and concentrated HNO3 in presence of concentrated H2SO4. And what is the major product? That is what they have asked. Now try understanding this, what reaction it is. It is electrophilic substitution, electrophilic aromatic substitution. This reaction is what? Ask me this. It is electrophilic substitution, or I'll write aromatic substitution. Electrophilic aromatic substitution. Okay, this is your chlorobenzene, and let's say there is a electrophile E+. Electrophile means it is electron deficient species. Obviously the substitution will take place on the benzene. Remember, there are hydrogens over here. These are the hydrogens which we don't write or don't show in the structure. One of the hydrogen will be replaced. Now where it will go, whether it will go at a position 1 where this E will go at 1 position, or a second position, third position, fourth, fifth or sixth itself. Who decides that? See, if it was a plain benzene, no substituent on that, it was just benzene, simple benzene, then any position, all positions are equivalent. Understand? Try to recollect the GOC, General Organic Chemistry, where we were understanding about the directive influence of the substituents on a group. So this group is what? This chlorine is known as a ortho para-directing to incoming electrophile. Okay. So here, if electrophile is coming, the one product you will get, the major product is Cl and NO2. Okay, and the other product, what you will get over here is this. Like this is what these are what are the reactions which we are learning. This is major product, this is major product, and this is minor product. Obvious reasons are that close approach, lot of repulsion, less stability, they are far apart, repulsion is less, stability is less. Like this is the major product. So I'll write the product, you try to recollect the things. Electrophilic aromatic substitution, we'll learn halogenation, then nitration, Friedel-Crafts acylation, Friedel-Crafts alkylation. All these reactions falls under the category of the electrophilic aromatic substitution. Now, okay, I have written NO2 over here. So for that, electrophile should be what? NO2 plus. This is the electrophile which is generated from HNO3 and H2SO4 combination. Okay, this is the electrophile which is generated from that. So electrophile one will go at ortho and other will go at para position. So para is always major. This is major. So they have asked about what? They have asked major product. Understand? They have asked about the major product. So major product will be this. Now just writing the product is not important for the boards. For boards, writing the product is not, that is not enough. So what we can write is para. At para position, there is nitro, or C comes first. Para, chloro, nitro, benzene. Okay. So only this is the major product. You are not writing the minor product over here. Fine. What about this? 623 Kelvin, 300 atmosphere pressure, this reaction. NaOH is there, 623 Kelvin temperature. How much is pressure? 300 atmosphere pressure. 300 atmosphere pressure in the presence of acid. Very harsh or extreme conditions. These are very, you understand 300 atmosphere pressure. What over here is done is we are trying to do the substitution. We are trying to do the nucleophilic substitution on the benzene, like OH minus. NaOH is a good source of what? OH minus, strong base, right? It is done this way. This OH minus will replace this. It is a substitution reaction. Understand, at normal conditions of the temperature and pressure, this substitution is impossible. Nucleophilic substitution on benzene is not possible because benzene itself is electron rich and OH is also electron rich. But this process is possible only because of this condition, very high temperature. 623 Kelvin is a very high temperature and 300 atmosphere is also very high pressure. This substitution usually doesn't take place at normal conditions of the temperature and pressure. There are reasons also which are explained in NCERT nicely there, because there is there is partial double bond character. That is one reason. This is one reason. Partial double bonds are difficult to break. Electronegativity of this carbon is little higher normally, so that shortens the bond length. Then even if it is go via SN1, carbocation forms over here, then it will be not stable. So many reasons are there, but if you want to just learn the reaction and get marks for this exam, then over here this will happen. Understand? This will happen provided these conditions are there. NaOH 623, 300 atmosphere pressure. These conditions are there. Or other conditions like you put more NO2 groups over here. Those reactions are also there. So what product you are getting over here is a phenol. Nucleophilic substitution reaction is mostly, very difficult to do on benzene, but in the extreme condition it is possible. Right? So these two questions. So E is what? Our E is this one, and G is phenol. OH can be on the top also. What type of configuration? Okay, second type question. What type of configuration is shown by bimolecular nucleophilic SN2 reaction? SN2 means bi. So it is just what happens over there. We had understood this differences. Configuration. Basically, it is inversion of the configuration. You can write this. The structure. Inversion of configuration. The configuration of the structure changes after substitution of the nucleophile on haloalkane. Right? Okay. From the compounds 1-bromobutane, 2-bromo, 2-methylpropane and 2-bromobutane, the decreasing order of the boiling points. First, to understand this concept, you should know how to write the structure. You should know to decode the structures from name to the structures. We'll write the structures over here. First, like 1-bromobutane. How to write this 1-bromobutane? From where to start? First we'll put bromo or carbon chain. First rule, whenever any name is given to you, how to decode that into a structure. The first rule as a student you should follow is butane. You have to count the number of carbon. But, like pent, hex, these names, you will be looking for these names. Hex, hept. So but means there are 4 carbons. Hope everyone knows this. Butane, but means 4. Then prop means 3. Eth means 2. Meth means 1. Pent means 5. Hex means 6. Hept is 7. Oct is 8. This way. So but means there are 1, 2, 3, 4 carbons on a parent chain. On first carbon there is bromine. That's it. First carbon. I'll number this 1, 2, 3, 4. To satisfy the valency, I'll put CH3, 3 hydrogens. Over here I'll require 2, 2 and 2. This is the compound which I am writing 1-bromobutane. 2-bromo, 2-methylpropane means propane. They are saying that parent chain there are 3 carbons. 1, 2, 3. Like this is 1 carbon, this is second carbon, this is third carbon. On second carbon there is bromo group, and also on second carbon there is what? Methyl. This is CH3, this is CH3. Right? This is 2-bromo, 2-methyl. Parent chain is 3 carbon over here. So propane. And last structure is just 2-bromobutane. Last structure is this way. 2-bromobutane. Here is the Br. This is CH3. This is H, CH2. CH3. This is numbering 1, 2, 3, 4. So this is 2-bromobutane. This is 2-bromobutane. If you see, basically, mostly compounds having same number, same type of atoms the boiling point will depend upon the intermolecular forces, okay, or intermolecular forces are directly proportional to the molar mass. And if the molar mass, if the intermolecular force is very high, which holds the molecules together, then the boiling point is very high, right? But over here, if you see, all these are isomers, I'll write C4, 1, 2, 3, 4, how many hydrogens? 6, 7, 8, 9, H9 and Br. C4, H9. Over here there are 1, 2, 3, 4, 9 hydrogen, C4, H9, Br. This is also C4, H9, Br. So for isomers, the boiling point is inversely proportional to the branching. Make a note of this. Boiling point for isomers, what is the meaning of isomers? Same molecular formula, but different structural formula. For isomers, boiling point is inversely proportional to branching. More is the branching, less is the boiling point, right? So in which case there is maximum branching. This is the one where there is maximum branching. Here there is little less of branching, and here there is least branching. Least branching means maximum boiling point. So 1 bromobutane, then what? 2 bromobutane, and last is this. So your answer becomes this: 1 bromobutane, 2 bromobutane, and 2 bromo 2 methyl propane will be the one which will be having the least boiling point. Fine. Sometimes what happens is recording sometimes stops in between because of some update, and like even if I put that on a flight mode, sometimes it happens. That's why I have to check it again and again whether it is working. It happened many times that I'm just recording over here, I'm talking and the camera is not working only. Okay, next. When chlorobenzene reacts with chloromethane in the presence of sodium and dry ether, the major product obtained. Now, this is not the direct reaction which is given. You have to know. Like basically the reaction is talking about this. When chlorobenzene, this is your chlorobenzene, reacts with what? Chloroethane means CH3, CH2, Cl in the presence of what? Sodium in dry ether. There also I mentioned, I guess for only one reaction, dry ether. All the reactions takes place in a dry ether only. So dry ether. So what? This is what? Can someone comment and tell me over here? Yes. Pause the video for some time and tell what reaction is this. This is aryl halide. This is chloroethane. This is chloroethane, means alkyl halide. This reaction is Woods fatigue reaction. Understand? Aryl halide and alkyl halide, Woods fatigue reaction. So the compound what you will be getting over here is this CH2 CH3 plus 2 moles of NaCl. So this is what? Ethyl benzene. This is ethyl. Ethyl benzene. Right? This is the reaction. If you feel that my content is good, it is helping you out for your preparation, boards preparation, please subscribe my channel. Subscribing is free for you, but it gives me, it motivates me to do more such videos. share this video with your friends, like, comment. Okay, so we'll go ahead. Okay, again there are compounds given, names are given, you need to know, you should know how to decode the structure. Again, this question is that way. The compound that undergoes substitution nucleophilic reaction with complete inversion of the configuration. Can someone tell me, can you comment this and tell me? Complete inversion of configuration means they are talking of what? It is SN2 reaction. I have illustrated these 4 differences at the beginning, which is basic requirement to know haloalkane and haloarene. SN2, they are basically talking, they did not mention, the question did not mention directly the inversion of the configuration, but did not mention SN2 directly, they said inversion of the configuration. So go to the differences and understand that SN2 gives inversion of configuration. Inversion of configuration. Compound that undergoes substitution nucleophilic reaction with complete inversion of the configuration. First we'll understand what kind of alkyl halide these are. Among A, B, C, D, we'll understand the degree of the alkyl halide, whether it is primary alkyl halide, secondary alkyl halide, tertiary, right? So anybody finds, small difficulty while learning, you may get a small difficulties like, what is primary alkyl halide? I don't know to identify primary alkyl halide, secondary alkyl halide. Even if you feel it that way, you are not able to understand, you can just message me on the number given below. Okay, it is there on my channel. You just message me personally. I can sort that through WhatsApp. If not possible, you can just have a short online session in my free time. Okay, but if it is possible to clear your doubts through WhatsApp, I can do that, no issue. So what happens, whenever you learn organic chemistry or any subject, you need to develop that vocabulary. Vocabulary means what? Like I may talk over here about the primary, secondary, and for a teacher it becomes impossible sometimes to describe every short term. Then main concepts remain there only. So if you feel that you are not understanding one term, don't feel shy. No difficulty is silly. No difficulty is silly. Understand, my dear students, that like this after 12th standard you may go going to different colleges. Always have that guts to ask difficulties and don't consider your doubts are silly. No doubt is silly. I don't consider any doubt is silly. So as asking doubt is a sign of learning. When you ask doubt, that means you are learning. You are not getting doubt means you are not learning. Okay, so always keep this habit of asking doubts. Understand, at the beginning your doubts may be silly, you may be feeling it silly, but over a period of time you will understand that your quality of asking the doubts will have improved, right? The quality of asking doubt is increasing means what? Improving means what? Your subject is improving, right? That is what the outcome of asking doubt. Okay, here 2-bromopropane, we'll write the structure. Propane means, over here it's propane, means 3 carbons on a parent chain. I'll write the structures first. 1, 2, 3, bromo, done. So here I'll put 3 hydrogens, 1 hydrogens. I'm putting the hydrogen as to satisfy the valency. This is A. What is B? 2-bromo, 2-methylpropane. Okay, 2-bromo. Propane means 3 carbon, and here there are this way. What is C? 1-bromopropane. This is 1-bromopropane. And D is what? 2,2 dibromopropane. Propane only, all are 2,2 dibromopropane. For SN2, which alkyl halide is favorable? Primary alkyl halide is always favorable. Primary is more, primary alkyl. Then secondary. Primary alkyl halide. Primary alkyl halide is more favorable. For what? SN2 reaction. Comment the degrees of A, B, C, D. Pause the video for some time and comment the degrees. See, you don't have to do passive learning. You need to do active learning. Active learning happens always in a class. And when you learn something online through YouTube videos, you can participate just by commenting. Okay, that is what is active learning. Like, it is not possible, no, this video is already recorded. I cannot ask, I don't know who is watching. But of course, you can participate by commenting what is A, B, C, D, right? So over here, A is what? Like, this Br is connected to this carbon, this is directly connected to 2 carbon, therefore this is secondary alkyl halide. This halide is connected to this carbon, this is directly connected to what? 3 carbons. So this is tertiary alkyl halide. This one, this Br is connected to this carbon, this is directly connected to only 1 carbon, right? This is CH2. So this is primary alkyl halide. What about this? This is connected to this. This is also secondary alkyl halide. Right? So answer is what? C. That is primary alkyl halide. 1 bromopropane. 1 bromopropane. This is your answer for this question. So over here, yes, compound which has asymmetric carbon atom in the following compound. Now you know, like one example I have solved. What is asymmetric and symmetric carbon? You can also solve this. Pause the video for some time and try to decode the structure and try understanding among this which compound is asymmetric carbon atom. So over here, the first one, if you write the structure, I'll just write this A, not a MCQ, C, and this as D. Okay. A, I will write open chain. 1, 2, 3, 4. This is CH3. This is not asymmetric. This is also not asymmetric. Sorry, this is symmetric carbon. I mean, this is not chiral one. This is also not a chiral one because it has 2 hydrogen. This is also not a chiral one. This is also not a chiral one because here all carbons are having at least 2 similar groups. That is 2 hydrogens are there. Then what about B? What about B? B is CH3, CH2, not asymmetric, not asymmetric. Let's check, this hydrogen is there and there is one Cl and this is there. So this carbon is asymmetric. This compound is optically active. This is ethyl group, direct connection. This is ethyl group, this is hydrogen, this is methyl, and this is chlorine. All 4 groups are different. So answer is this. You can check others also. Over here also we'll check. The C1. This is that carbon. There are 2 methyl groups on this. There are 2 methyl groups on this. This is hydrogen. This is CH2, Cl. No carbon is there where all 4 groups attached to it are different. So this is also not the answer. And last one, D, I'll write it this way. CH3, CH3, CH3 and Cl. So the answer is this one. Okay. I think this was the year 2022 where the question paper was totally MCQ. Many MCQs we are getting over here. Okay. In the following reaction, compound X and Y. First we'll understand this reaction. First compound they have given over here is this. This is your benzene. Very clearly you have to write. chlorine, right? Cl2 and FeCl3, right? Cl2 and FeCl3. This is in dark. This is X. You will get some product X, and then there is CH3COCl, CH3COCl, anhydrous AlCl3. What you get over here is two structures. This question is for obviously for 2 marks. No, 1 mark. See, benzene, over here we have to understand that the reaction, I'll solve this part, X part. I'll solve the X part to get X. In that, what will happen, step 1 is that the reaction between chlorine plus FeCl3. We know that this is something, we know that Lewis acid. This compound is Lewis acid. This compound is Lewis acid. This is always in need of the electron. So after breaking this bond, a chlorine and a chlorine bond, after breaking this bond, what will happen? You will get is Cl plus and a FeCl4 minus. And this is the electrophile which is generated. Electrophile which is generated. Okay, electrophile which is generated. And this is the step 1 of to get the product. This, I am just talking about this. And step 2 will be what? Step 2 is this. You take the benzene, this benzene, and you do the substitution of the electrophile Cl plus. You do it on any positions of the benzene. Now there is no ortho para because no group attached to it. All carbon atoms are symmetric over here. So what you get over here is the chlorobenzene, electrophilic substitution. I'll write over here. This is electrophilic aromatic substitution, right? Means one of this is electron rich, will attack electron deficient and will try to form the bond. Whether you put Cl here, everywhere it is equivalent. Means what is my X over here? I'll write the X component. What I am getting is this is X. Chlorobenzene. Chlorobenzene is X. And then you know what is this reaction? This is Friedel-Crafts acylation reaction. This is also electrophilic substitution reaction, but over here you are doing it on the chlorobenzene. I'll talk about the second part, that is Y product. The reaction is this way. You already got this as X. This is our X, which is chlorobenzene. This is our chlorobenzene. And what reaction you are doing over here? You are doing CH3 C double bond OCl, acid halide or ethanol chloride. Yes, no? CH3COCl in the presence of anhydrous AlCl3. It is again electrophilic aromatic substitution reaction. This will direct an incoming electrophile to 2 positions. One is ortho C double bond OCH3 and other is para C double bond OCH3. This is the major product. This is the major product and this is minor product. You have to write the major one always. Mechanism wise, if anyone is interested in learning the mechanism, you can just stay in this. Otherwise, you understood this reaction, okay, you just go ahead, skip this part and go ahead. I'll just tell you, because what gives me more satisfaction is telling the explanation. This gives me more satisfaction. Just doing the dry reaction don't give me that much pleasure. So step 1 is what? Generation of an electrophile. Generation of an electrophile. Electrophile is generated. How? The reaction between this CH3 C double bond OCl, ethanoyl chloride, will react with aluminium chloride. This is Lewis acid, which is always in need of the electron. Electron deficient है, octet complete नहीं है. There is no octet. Octet is not complete, right? So what you get is CH3 acyl group, positive charge, and AlCl4 minus. So this is the electrophile which is generated. This is the electrophile which is generated. And then step 2 is substitution of this electrophile. Substitution of electrophile on chlorobenzene. Chlorobenzene means you have chlorobenzene, your electrophile is this C double bond O and the positive. So I'll show the major attack here only, right? You get this major product Cl. Right? So what is the answer? Answer X, chlorobenzene, and this chlorobenzene, and this option D will be the correct one for this. Options were given. That's why, you know, this question was slightly complex. This question was slightly complex. Complete the following reaction and write the names of the major product form. Main product form. This reaction we have done just now. CH3COCl. Alcoholic, okay. So first reaction is this. First reaction CH3, CH2, CH2, Cl. AgCl. AgCl. AgCN. Okay, what is the product over here they have asked, and also the name. Name will be, see, AgCl, when you talk about this question about the cyanide getting substituted, okay, basically substitution is always taking place from the electron rich to the electron deficient. We need to identify this. So I'll write the small mechanism. So whenever bond forms, the electron rich attacks the electron deficient. Attacks means donates its electron to the electron deficient. And the new bond is formed and the old bond is broken. Which old bond is broken? The weakest one. Weakest one is the longest one. Right? How do we understand? For that we should have the knowledge of what? Periodicity. How the trends of the atomic radius changes. Don't consider organic is like independent. Lots of concepts from the inorganic chemistry is also used over here, right? We'll talk about this CH3, CH2, CH2, Cl. Now this is AgCN. Understand that AgCN is a covalent compound. It is covalent. Okay, covalent means what? Ag, carbon and nitrogen. Over here, this is the lone pair, this is the electron rich. So over here, this will attack over here. Nitrogen will get attack over here. And what you get, the compound is CH3, CH2, CH2, N, C. Why only this carbon? Why it did not attack on this carbon? Why it did not attack on this carbon? Right? Why only that carbon? Understand that this is connected to the electronegative element. Again, you have to know what is electronegativity, because of which there is a partial positive charge on this carbon. So electron rich, this is carbon, electron deficient, right? That's why this is the thing which you are getting. Means over here plus charge, minus charge. Isocyanide, basically you get the isocyanide. This is called as isocyanide. But in this reaction, okay, I'll write the product. CH3, CH2, CH2, NC. Okay, isocyanide. If in this reaction, instead of AgCN, there was a KCN given. If CH3, CH2, CH2, Cl, and the reaction was, let's say, KCN. This is ionic compound. Understand, this is ionic. Okay, ionic means what happens is that it is broken into two in aqueous medium. You get K plus and a Cn minus is on the carbon. Now this is more electron rich compared to the lone pair, right? In this case, that Cn carbon will get connected. Carbon will get connected over here, and the compound you get is cyanide. The compound what you get is a cyanide over here. C is getting connected. So understand, KCN or AgCN. If it is AgCN is given, then NC, and KCN is given, then cyanide. You can understand this way, right? This I have done just now. Previously, I will not do it again. Okay, I will not do it again. Now over here, what about this one? CH3COCl. Compound is second, third one. Third reaction is written this way. CH3COH. Sorry, Cl, no it is. This is Cl. And CH2, CH3. And they have given KOH, alcoholic, right? Or sometimes they will write the alcohol, ethanol, methanol, something like that, alcoholic. Understand, over here there is a elimination taking place. I'll write. What reaction is this? Beta elimination reaction. Beta elimination reaction. First I'll explain what happens in this reaction, how to identify whether it is addition reaction or a substitution reaction as far as boards are concerned. Okay, so beta elimination, this reaction is also known as dehydrohalogenation. Dehydrohalogenation means you are removing hydrogen, you are also removing halogen from this. Elimination leads to the formation of the alkene. Dehydrohalogenation. I'll write this CH2 as this way and this CH3 as this way. Okay, I'll show it separately. Dehydrohalogenation means your compound is this way. CH3 I am writing this way. Hydrogen, Cl, and the CH3. I'm writing it this way. Beta elimination. Understand, whenever there is alcoholic KOH or any alkali base like NaOH with alcohol, understand you have to do elimination. You have to remove hydrogen and chlorine. Now which two sets you are going to remove? You can remove this HCl or you can remove the other HCl, right? Dehydrohalogenation. Either you can remove this or you can remove this set. Let's say I'll call this as A set and the B set. If you are removing A set, understand the double bond will be formed over here. Elimination leads to the formation of the double bond, right? And if it is B set, then double bond will be formed over here. This is a big topic. Again, elimination. Over here, both the alkenes, you are getting two possibilities of the alkene, right? This alkene, right? I'll write this as a minor alkene and this as a major. Why? This is based on the Seydt-Zieff rules. More the number of the alkyl group on the either side of the double bond, more stable will be the alkene. Seydt-Zieff rule, which is again on the basis of hyperconjugation. More number of the alpha hydrogen, more is the stability. Like this is your double bond, this is your alpha carbon, this is your alpha carbon, and the hydrogens present on the alpha carbon are called as what? Alpha hydrogen, right? So here there are 3 plus 3, 6 alpha hydrogen. Here there are just 2 alpha hydrogen. So this is your major product. How to identify the stability of the alkene. So your product over here, major will be this CH3, CH, CH3, but 2-ene. Now whether the compound, like elimination reaction will undergo or substitution. Now there is one more reaction which I'll tell you. If your reaction is this way, let's say CH3, Cl and CH2, CH3, and they have given a base only, let's say NaOH, and they have written instead of alcohol, they have written AQ. AQ stands for aqueous in the water medium. Or let's say KOH also they have given, and if it is written AQ, mostly they will not write KOH, they will write NaOH. But even if it is KOH and they have written aqueous, understand it is what? It is not elimination, it is substitution reaction. Substitution of OH minus, right? So this product Cl will be replaced over here. You will get the alcohol over here. You will get the alcohol, that is butane 2 all will be the alcohol. Understand difference. If it is aqueous and the base, it is a substitution reaction, and if it is aqueous and if it is base and the alcoholic, write this alcoholic, it is written ALC, or they mention the alcohol, which alcohol. Understand, you should undergo elimination reaction. Yes, all 3 reactions sorted over here. Okay. Okay. Hope this is visible again. Write the structures of the compound A, B, C, D, E, F, means whole, all of this. A, B, C. First we'll handle this A and B. Okay, A and B. What is written? A is written CH3, 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 Br. And what is written? Alcoholic KOH. It is written alcoholic KOH. Alcoholic KOH. A little amount of the heat. So what reaction will undergo? Can you comment? Please pause the video sometime. And just now I told you, if it is alcoholic, elimination reaction. So over here there is elimination. Which elimination? Beta elimination or dehydrohalogenation. Beta elimination. And beta elimination means what? There is CH3, I'll write CH2H. You remove this hydrogen. Only one possibility is there. Everything is symmetric. So what you get is CH3, CH3, double bond CH2. Means you get this alkene over here. That is 2-methyl propene. And next thing, what they have written is HBr. HBr. In the presence of what? Peroxide? Yes, it is written in the presence of peroxide. There are 2 reactions. HBr, like you take a alkene, there is called as Markovnikov's reaction, MAR. Markovnikov's reaction. I'll illustrate this Markovnikov's reaction. Let's say you have this asymmetric alkene, plus HBr. It will follow Markovnikov's rule. Now what is Markovnikov's rule? Negative part of the adding species will go to the carbon which has less number of hydrogen in a carbon-carbon double bond, right? Negative part of the adding species. This is the negative part, this is the positive part. Br is a negative part. It will go to the carbon which has less number of the hydrogen. And H will go over here. Means you will get CH3, CH, Br, CH3. This is Markovnikov's addition. And there is anti-Markovnikov's addition. There is anti-Markovnikov's addition. Anti-Markovnikov's reaction or the addition, which is opposite of what I just said. That is, the negative part will go to the carbon which has less number of the hydrogen. Just Google the statement, you will understand. So if this is there, you have this alkene, similar alkene I am taking, and HBr. For anti-Markovnikov's, what is very important is peroxide. They have written peroxide. Peroxide means oxygen is in a -1 oxidation state, H2O2, benzyl peroxide, any peroxide. So here opposite of this means Br will go to the carbon, negative will go to the carbon which has more number of the hydrogen in a carbon-carbon double bond. Means this CH3, CH2, Br here. So whenever you are doing the addition reaction, addition of HBr to the double bond, what happens? If it is anti-Markovnikov, how to identify? Peroxide. Without peroxide, over here it will go. So in this reaction, where the Br will go? Anti-Markovnikov's means Br will go to the carbon of this. Means the product, what you are going to get is this CH3, a hydrogen will come over here and the Br will come to the carbon which has more number of the hydrogen. Name of this 1, 2, 3. Name of the compound, right? IUPAC nomenclature. Bromo and methyl. B comes first. So I'll write the name of this. It is 1-bromo. 1-bromo, 2-methyl. These are prefixes. Then word root is prop. 3 carbons on a parent chain. Prop. No carbon-carbon double bond. All carbon-carbon single bond. So ANE. Right? This is the thing. Yes. This reaction, Cl2, in the presence of light. One minute, I'll just drink water. Okay, second reaction, that is methyl benzene in the presence of chlorine and the UV light. This is methyl benzene, that is other name for this is toluene, or you call this as a methyl benzene also, methyl benzene. This is reacted with chlorine, Cl2, in the presence of UV light. Understand, this reaction is not a electrophilic substitution. Electrophilic substitution will happen anywhere on the benzene. This is free radical halogenation. How do I identify? UV light and chlorine molecule is there. Halogenation. So free radical formed in the intermediate. Like that substitution will take place over here. I'll not go in much detail, but still, okay, I'll write the intermediates over here. Possibilities, how intermediates are formed. CH, let's say this is CH2, I will write, I remove one hydrogen in a homolytic cleavage. This is the free radical or possibility. I will write all the possibilities. Here may be a free radical formation here. These are the possibilities, all the possibilities. Among this, where the free radical is most stable, this is the most stable because it is in conjugation. Pi, sigma, pi. Free radical is intermediate. Intermediates are never stable on the pi bonds. Here it is pi, sigma, pi. It is not present on the pi bond. So this is most stable. So what compound you are going to get is substitution over here. Chlorine will get substituted over here. This is free radical. Substitution, right? And this is our C. This is our C. This is our C. Further, you see what is written over here? Okay, this is the intermediate. This is the I'll just clean this. Aqueous KOH. Many students make this mistake. Whenever they see KOH, they directly do elimination. KOH is not the hero. KOH, when, in which medium it is present? If it is present in aqueous medium, it will undergo what? Substitution. If it is present in alcoholic medium, it will undergo what? Elimination. So this is aqueous, it is written. So here a substitution reaction is going to take place. KOH, in bracket it is written aqueous. So what will be getting substituted? Cl will be getting substituted over here. CH2OH. Very good source of what? This KOH is good source of OH minus. Right? Last reaction of this, not the session. There are more reactions. Still students, this is a long, like almost more than 1 hour I guess. We are learning over here. If you are watching video till over here, I'll say that you are, really super motivated to study and get good marks in your board exams. You feel that this video is again helping you out. Please subscribe. It really motivates me to make more such videos. Okay? Subscribing is free for you, but it helps me a lot. Over here, this reaction I'll solve over here. This is alkyl halide. This is what? CH3Cl. Reaction with the magnesium. You get E as a Grignard reagent. What you will get is CH3MgCl. This is known as Grignard reagent. Methyl magnesium chloride. And further, if you do the hydrolysis, this is what the water you are adding. What you get is, so I'll show you. RMgX is a general representation of the Grignard reagent. When you do this, you get the Grignard reagent. Further, if you do the hydrolysis, what you get is R, or you get the alkane actually, RH plus MgOHX. Means over here F will be what? Major product. It will be right here. It is CH3H plus MgOHCl. CH3H means what? It is CH4, no? It is methane over here. So we understood what is A. In this case, A was 2-methylpropane, B was 1-bromo 2-methylpropane, C was alcoholic KOH, D. So we have sorted out with all the reactions over here. Write the chemical equation to show how you will convert a chloride to nitroethane. ethyl chloride to nitroethane. First we'll take this. You want to convert ethyl chloride to nitroethane, CH3. Okay, second reaction, chlorobenzene to 4-chlorotoluene. Okay, what I feel is this reaction is a kind of from the amines part. First we'll have to convert to amine, and then if you oxidize that amine you will get a nitro group over here. We'll not do this part, we'll do second. When amines will come, I'll do it that time. Chlorobenzene to 4-chlorotoluene means I'll do the second one. You need to convert chlorobenzene, this is our chlorobenzene. You need to convert this to what? 4-chlorotoluene. This is chloro, this is methyl. I'll write the reaction. Please identify. CH3Cl anhydrous AlCl3. This reaction is again electrophilic aromatic substitution, and this is known as Friedel-Crafts alkylation reaction. This is Friedel-Crafts alkylation reaction. With this you are going to get this 4-chlorotoluene. This is 4-chlorotoluene. Those students who want to know the mechanism, stay over here. Otherwise you can just go ahead if you are just preparing for boards. Step 1, generation of an electrophile. First, how electrophile will be generated? CH3Cl, and this is the anhydrous AlCl3, not Cl4, Cl3. How it will be generated? This way. Lewis acid always need electron, so this is AlCl4 minus and CH3 plus will be generated. CH3 plus. Since chlorine is more electronegative, chlorine will go and carbocation will be formed on a carbon. So this is the electrophile which is generated. Right? Step 2 is what? Step 2 is substitution of electrophile on chlorobenzene. This is your chlorobenzene. And what is the electrophile? This. Again you will get two products, ortho para. I will show the major one, para one. This is the major one. Right? This is how you get the products. Write chemical equation to show how you will convert 2-chloropropane to 2-iodopropane. A. 2-chloropropane to, like 2-chloropropane is this. CH3, 2-chloropropane. You need to convert this to Iodopropane. This is one of the halogen reaction, halogen exchange reaction. It is Phil-Kinston reaction, that is AGI, halogen exchange reaction. Okay, I forgot to mention the thing. Yes, this question, students, this question is for 2 marks. Question asked is, write chemical equation to show how you will convert 2-chloropropane to 2-iodopropane. This reaction is again a halogen exchange reaction. That is this reaction. Okay, general reaction, if you want to know for this, it is this alkyl halide is reacted with a silver iodide, and which halogen is exchanged over here, Ri and AgX. Halogen is exchanged over here. This is what that reaction is, and it comes under the category of the halogen exchange reaction. It comes under the category of the halogen exchange reaction. So over here you need to prepare 2-chloropropane. Like I will take this R part as a propane, CH3, CH2, chloropropane. This is my this will be my R part. Okay, and I'm reacting it with a silver iodide, and the compound what you are going to get is 2-iodopropane. Okay, so it is this, a very basic reaction, simple reaction, no twist and turn, direct reaction, and byproduct is not us, AgCl is the byproduct, that is the precipitate you are going to get over here. This is the one reaction. Second reaction, what is asked over here is a benzene diazonium chloride to chlorobenzene. This is very simple. This is a part of a Sandmeyer reaction. This reaction is a second step of the Sandmeyer reaction. Sandmeyer reaction takes place in 2 steps. That is primary aromatic amine, that is aniline is converted to diazonium salt. Here they have just asked a second step about the Sandmeyer's reaction. So that is diazonium salt. This is your diazonium salt, N2 plus Cl minus. You add what? Cu2, Cl2, because chlorobenzene you need to prepare, or Cl. Here oxidation state of the copper is +1. Okay, oxidation state of the copper is +1, and the compound what you get over here is, this bond is very easy to break. Usually this bond is not easy to break, but in this case because here this diazonium salts nitrogen is having a positive charge. That's why this bond is very easy to break. The question, like diazonium salt structure is this way. Nitrogen, double bond nitrogen. There is a positive charge over here, and the counter ion is Cl minus over here. Like to give stability to this, it breaks very easily. And it is said that in thermodynamically, it gives nitrogen. Entropy is increased. If we go into more depth of that, nitrogen gas will be released over here. Now this is what the chlorobenzene is. This is what the chlorobenzene. This is the product. And these are the 2 simple reactions were asked. 2-chlorobutane reacts with hot alcoholic KOH, the major product. Okay, this is again a elimination reaction. How do I understand? It is alcoholic KOH. Okay, so over here 2-chlorobutane. First we'll draw the structure of 2-chlorobutane. CH3, CH. This is 2-chlorobutane. I'll show this CH2, one hydrogen over here, and this CH3 has one hydrogen over here. Elimination. Either you can remove this set or you can remove this set, A or B, right? So if it is going via A, means you are removing this first set of the HCl, that is beta elimination. This reaction is also known as a beta elimination, or also known as dehydrohalogenation. Now reason dehydrohalogenation, why? Removal of the hydrogen and halogen. Beta, why? Because this is carbon where the halide is attached, this is alpha, this is beta. We are removing the beta hydrogens first. Mechanism, I will not discuss over here, because if I discuss the mechanism for every reaction, what happens is the video becomes very long. This video is made with the intent that your boards are revised. Okay, boards preparation becomes very easy and quick. Okay, so you can, for this, if you want detailed explanation about the video, detailed explanation about the elimination, how it happens, you can of course refer to my GOC part, General Organic Chemistry. There I have explained about how elimination happens, beta alpha eliminations. So here it is this CH3, CH, this is what the alkene, and if it is via B, then this is CH3, CH2. Like these two possibilities. One is but 2 in, but 2 in, and this is but 1 in. Right? But 2 in will be major according to the Sedzeff rule. This is major and this is minor. More the number of the alkyl groups on the either side of the double bond, more is the stability of the alkene. The rule is from the basis of what? This rule is from the basis of the hyperconjugation. More is the number of the hyperconjugating structure, more is the stability. Or I can also say that more the number of the alpha hydrogen, more is the stability of the alkene. Here there are 6 alpha hydrogen. If you count, this is alpha and this is alpha. 3 and 3, 6. There are 6 alpha hydrogen. That's why this is more stable. Just telling you how we decide that which particular alkene is more stable. Here there is just 2 alpha hydrogen, so this is less stable. Answer is but 2 in. Answer is but 2 in. Last question of the session. Question asked is over here, this PCl5. First question, direct substitution over here. There is, sorry, not benzene. This is CH2OH and this is PCl5. Now PCl5, if you see, it is very good source of what? Good source of Cl minus. Very good source of Cl minus, which is acting as a nucleophile over here, which is acting as a nucleophile. There are so many carbon, this is a carbon, this is carbon, this is carbon, but this nucleophile will attack the electron deficient, because this carbon is the electron deficient. This, because oxygen is electronegative, it pulls the electron density towards itself and it makes the carbon deficient. This carbon is the most deficient one, so this is my Cl minus, this is my Cl minus, which will attack means donates its electron to this carbon to form a new bond, and this will be gone. So what you get is CH2. Now whatever I have shown, these arrows, this is called as a mechanism, right? This is not expected from the student to write in the exam. You just write this product, you will get 1 mark for this. I have just shown you that you understand what is electron rich, nucleophiles always attack electron deficient, a mechanism, kind of a mechanism, so that you know this, along with the preparation of the board, you get some idea about the preparation of any competitive exams you are answering, NEET or JEE, or for that matter any entrance exam. This simple concepts will help you, right? So this is the product you will be getting. Next reaction, what they have shown over here is this. Second reaction, that is CH3, CH2, CH2 HBr. Can someone comment and tell me what is the name of this reaction? It is, yeah, pause this video sometime and think of the product. This is Markovnikov's reaction, where negative part of the adding species goes to the carbon which has less number of hydrogen. If peroxide was there, I would have said opposite, that is anti-Markovnikov. So Br is the negative part that will come over here because this carbon has less number of the hydrogen in the double bond. So your product is very simple. CH3, CH2, CH, Br, and hydrogen goes over here, so CH2 changes to CH3. Name will be 2-bromo-propane. Okay. So this is the end of this video where I have discussed most of the questions of the previous year's board, and I feel that I'm sure this video must have helped you to develop your organic chemistry concept in a better way. Again, I'll say, if this video has added value to your life, value to your preparation about the organic chemistry, about the haloalkane, haloarene. Okay, just like, share and subscribe.